Hello students, hello. Okay, welcome to the class students. We will start. Today we are going to understand about the agent with the memory, right? So when we talk about building the agent with the memory, right? Today we are going to start with building an agent with the memory. And in our today's lecture, we are going to understand about the RAG, what is a retrieval augmented generation, right? What is a conversion buffer, and as well as what is a long-term fact. So whenever we talk about this RAG, right? It always gives you the more and more reactions. So when we start about the embedding part, we are going to use the Hugging Face embedding, all mini LM. You can see this person, right? And if I talk about the vector DB, we are going to use this chroma DB for a better approach, right? We can also swap with the another, it's called the face, right? It's from the Facebook itself. So whenever we are talking about this memory agent lecture, right? Today we are going to build something. It can store, it can save your all the data at a one step. Today we are going to use the LLM. It is a Gemini 2.0 Flash, and we also do have three layers. You can observe here conversion layer, long term, and then third one we do have the drag over medium. And we are also going to perform a live coding here, right, with the step by step approach. So just follow with me for more and more approach. What we'll do for students, we will try to understand what we are going to build. So if you observe properly, here we have the one simple flow. Let's suppose if somebody type a question here, right? If you are typing the question here, what we are going to perform, we will convert those questions into the prompt here, right? Let's say if I type the question here, then I'm going to convert those questions into the prompt. After that, we do have a certain kind of label as a layers as well as layer 1, layer 2, layer 3. And if we control all the layers, we are going to build a one full prompt for that. And for the LLM part, we do have the Gemini 2.0 Flash. So if you observe properly, student, this is how we are going to build. This is how we are going to understand simple architecture, how our project, how our today's lecture is going to work. So if you observe properly, we are going to build this different kind of files, such as the ENV file, right? For that, we will setup file. If I talk about the requirement files, in which we do have all the required libraries, we are going to perform. And if I talk about the config file, embedding file, right? Store.py, memory.py, and then PDF rag is also appear. So whenever we are talking about this multiple kind of file, we are going to understand each and every file. We are going to type each and every file one by one. So if you observe properly, whenever we talk about the ENV first, in which we will provide the ENV, that means the Gemini. As of now, we are going to use the Gemini as an LLM. So I must have to give the Gemini API key. And if I talk about the second option, requirement.txt. In the requirement file, we do have multiple package of the libraries. On top of that, we are going to build this project. And as well as if we talk about the config file, in which we have all the setting at a one place. Then it's come to the embedding file, store file, memory, in PDF file. So what we are going to build here, we will build a one by one file, step by step approach here. Okay, so let's get started, students, right? Let's get started. What we'll do first, right? I'm going to create a one folder here. I'm gonna create a one folder here, and I will give the name here, day number 3. Day number 3. Right? What I will do after that, I will open this folder here. So if you observe properly, let me open this new window here, right? And if I click on the file button here, and if I click on this open folder, so I can easily open my folder, day number 3 code. I will open this. So whenever we open this folder, What we need to perform after that, we need to create a multiple file one by one. So whenever we are creating those files, right, how can we do that? Number one, we will start with this .env file. So let's get started, students, right? Okay. Now, the number one file as we need to create is always going to be the step-by-step approach. So you must need to follow with me, right? So whenever we are going to create the file, you must need to follow with me, right? We are going to start this all the thing one by one, step by step. Will be up here, right? Okay. Now, a number one file we do have here, right? It has the simple approach here, right? Just give me 1 minute, students, right? Then we will start the coding here. So the number one file we do have, as I told you earlier, we are having this multiple kind of files: requirement, config, the embedding file, then lot of files, right? But as a number one, what we will do here, we are going to start with this config.py. We are going to start with this config.py. Let me create this file here, right? Here, I'm going to create a one file. It's called config.py, right? What I will do here, I'm going to use the import OS. Let me zoom in for you. You'll get a more idea here. I'm going to import some required libraries here. Import. Before we do this, students, what we'll do here, we'll try to create a one virtual environment here. This button here, three dots, terminal, new terminal. I'm going to create a one Python environment here. I would say Python and VNV and VNV. Right? So if I run this one, what we can do here, we can easily create this virtual environment. So if I create the virtual environment, we are going to set up each and every file. We will set up each and every file, each and every steps into this entire kind of virtual environment. After that, what I need to do here, I must need to set up my Python as well as, let me set up the latest Python here for a better approach. Right? And what we'll do after that, I'm going to delete this one, right? And what I want to perform after that, I'm going to create the virtual environment here, Python minus n vn vn. So if I create the virtual environment, what we can do after that, we can easily run the upcoming codes. Let's suppose my environment name is VNV. I would say VNV script activate. This is how we can activate our virtual environment. This is how we can activate our virtual environment, right? And if you observe properly, what we need to do after that, we are going to create the multiple files, config file, the requirement files, reg file, right? All the Python file will be creating one by one. Let me start with the config.py, right? As well as before we do that, what we need to do here, we also need to create a one requirement.file here for a better approach. Let's suppose we also need to import multiple packages of libraries. I will click on this apply button here, right? I would say requirement.txt, requirements.txt. What I will do here, I'm going to use the Google Gen AI as a latest package here, right? And I would say sentence, right? Transformers, I would say Chroma DB. Our lecture, our entire session is always going to be work on this one to one, right? You can also see, observe here. We are not going to deep dive into the theoretical concept. We will always work on the coding part, right? We will always focus on this coding part only, right? Phase CPU is here, and the PyPDF is here for the PDF chunking part, right? Python. We also do have the .env, the environment part, right? And after that, we also have the numpy for a mathematical operation, and we have fpdf2. Now, I do have this entire package of libraries. What we'll do after? I'm going to run a simple command pip install -r. I'm going to copy the path from here. Right click. You can observe copy a relative path. I'm going to paste it and hit that. This is how we can install the required package of the library which we need for our project. So when we set up each and everything, the virtual environment is done. The requirement file is also done, right? What we'll do after that? What will perform after? So whenever we talk about these things, students, we must need to understand a few basic concepts which we need to understand. When we start about the config.py, okay, let me come this part here. In the meanwhile, what we can do here, we can easily run this config.py file. We can easily set up the config file, each and every multiple file step by step, right? So when we talk about the config file, that means in which we will give the setup for all the config, all the one by one files, right? Let's wait for a few seconds more and we will start. This is how step number one, create a folder. Step number two, what we need to do here, we also need to perform to create a virtual environment here. Then we must need to enter into the virtual environment. And after that, what we need to do, we need to install the required package of the libraries. This is how we set up our entire project before we start. Let's wait for some time, students, then we'll start. Yes. Wait for some time, students, and we are going to move forward. So when we talk about those things, right, as we discussed earlier, step number one, what we need to perform here, we must need to install the required library of the packages, right? Then only we will move further. So if you observe properly, when we start here, step number one, we had created the one folder. After that, what we have performed here, we had just started with creating the virtual environment here. And if you create the virtual environment, what we need to perform after that, we must need to install the required package of the libraries. And after, we can easily move further. What we do here, students, we are going to start with the config.py, right? And let me write the code for that. Okay, we'll start with the import OS, right? Okay. So if you observe properly, here is working really fine. It's all done now. You can see. Now, if I talk about the libraries, packages, all the thing is going to be work really. We can easily move forward. So if you observe properly, when we talk about this config.py file, right? Import the OS. What we'll do after that? Yeah. I'm zooming the screen for you for a better approach. Then we'll start. From the .env, from my environment, what I want to perform here, I want to import my load.env, right? So if we do this thing, what we need to do after that, we must need to use a variable here, this one, right? Then we'll move further. And if you observe here, now our all the libraries from the requirement to txt file, our all the package of the libraries is installed now. That means we can easily use this package of the library in our entire project. We don't need any further setup here. We don't need any more setup here, right? So I hope so far so good. I hope so, right? So can we move further, students? Okay, yes. Now, if we talk about this API part, right? We are going to use Gemini. It's from the Google, right? We are going to use a Google Gemini API, and in which we will use Gemini 3.5 plus as a model, and we'll move forward. So I hope that's clear for everybody, right, students? Okay. So when we talk about this Gemini API, right? Let me also give it a try. But before we do that, I'm not going to, yeah, because we also do have the 1 hour of the limit as well, right? We also want to perform a lot of coding in this entire one session. So it's not going to be possible if you write one by one line, if you write one by one. So what I have the approach from you, if you observe this document, right? You can observe from this document in which we also do a couple of files, right? So when we talk about the config.py file, when we talk about this Python track, when we talk about the all the multiple files. What I will do from here, I'm going to copy the things from here, right? And I will open my VS Code, right? And I'm going to paste it here for more and more better approach, right? So if you observe here, this is how we are going to perform. But when we talk about those things, here, what we had performed here, we had used a package library. It's called the load. It's called the .env, in which we had imported the load underscore .env. This is how we will import this .env file into my entire project. And we already aware of that. We had used the Gemini API key. That's why we had used Gemini 2.0 Flash model from the Google itself. And for the embedding part, we have used a free model from the Hugging Face, right? It has all many LM L6 V2. And we also have the dimension for that 384 as a dimension part, right? And what is our main goal? I need to store my data. I need to store my work. Whatever the work we will perform in this entire project, I need to store somewhere else, right? That's the reason we do have use embedding part, right? And for the chunking part, for the rag part, right, we had used this multiple approach, like the top case, right? Top cluster is also here. If I talk about the Chroma DB is also here, right? So we have the two approach, students. Number one, they can start up with this Chroma DB, and as well as we can also use the phase as well. So we can switch between one to another from phase to Chroma DB, then from Chroma DB to the phase. So this is how we are going to set up this number one file. We had set up this number one file. It's called config.py, right? Config, that means we will give the configuration for my entire project. If we move further here, students, what we can see, we will build another file. It's called llm.py. So as the word suggests, large language model here, and as I told you a couple of times, we had used the Gemini API key, Gemini LLM model. So we are going to set up the one file. We must need to set up the one file here before we move forward, right? So I hope whatever we have discussed till now, it's clear to everybody, right? Okay. So when we talk about llm.py, what we need to give it here, we are going to use this Google. So I would say from Google, I'm going to import the Gen AI, right? And I will give from google.gen AI. I'm going to import types here. Import types. I would say import config. Right? I'm going to say as client, right, equal to none. And I need to create a one function. For that case, what I can perform here, I can use a def keyword to create a function in the Python. Def get client, right, global underscore client. If my client, if my client is none, then I will say another loop. If not, config dot Gemini API key, right? And I will say raise the error here if you do not find the config.py. Simple logic, simple approach, which we need to use it. Runtime error. If my model, if my LLM model cannot able to find, my LLM model cannot able to find this file, it's called the config.py file. If my LLM model cannot able to find this file, then what we have to perform, we need to say in the coding, we need to build one function. The function will automatically going to be raise one error. It's called the runtime error. It's called the runtime error here, right? Now, if you observe here, what we'll do here, we are going to say as a Gemini API key, Gemini API key, is missing. It's the message, we will get it whenever the runtime error is happening. It's the simple message we are going to get it when we got the runtime error issues, right? So if you observe here, Gemini API key is missing here. Gemini API key is missing. And I would say, please add it. Please add it in your .env file. Your .env file, right? This is how we are going to build it. Now, what we have to perform after that, we also need to perform a few things. But before that, what we are going to perform now, as I told you earlier, now I'm going to choose the llm.py file from here. Let me find out the llm.py from here. Right. Let me find the file here, llm.py. Okay, let me copy this entire file from here. But I just want to let you know the simple approach. How can we build, how can we set up each and everything. This is my second file. So llm.py, right? I'm going to copy this one. Let me paste it here. This is how we set up each and everything, right? Okay. So I hope that's clear to everybody, students, right? So far, so good. I hope whatever we have discussed till now, so we can easily move further, right? Okay. Now we are pretty much ready with the two files. Number one, config.py, in which we will give the detail about the configuration part. Number one, as we talk about Gemini API key, the Gemini model, right? And then embedding model, which model we had used. We had used a mini LM for the Gemini. For the LLM part, we had used Gemini model, right? And if I talk about the storage part, chunking part, we had already set up with each and everything. And as well as we had used for the storage part, we had used a phase, and we had already performed the chroma DB. This is how we set up the config.py file. But when we talk about the number two file, it's called the llm.py. Right? So in the llm.py, what we perform here, we were always going to use the simple approach. We will create a one function. It will give you the more and more output as if you do not, if the function, if this model, if this entire file structure, if you didn't find the file, it's called the config.py file, right? Config.py. If the LLM model cannot able to find out the configuration for our model, it will raise the error for us. What's the error here? We have the runtime error. We do have a runtime error here. This is how we are going to perform. This is how we're going to build this kind of two file config.py, llm.py. And as well as on the other part, in the llm.py file, what we do, we will generate a one thing here. That's called the system prompt. We will generate the one thing. It's called the system prompt. So when we write any prompt here, when we write any input here in our model, it will always give it to the system prompt here. It's the user prompt here. It will return the response text here. This is how we design the LLM and then config both of the file. So after that, what we need to do here, we also need to perform the third one here. That means we are going to work with the third file. It's called the embedding.py. So whenever we talk about the embedding.py file, what we need to do here, we are going to create one file is called the embedding here, embedding.py here, in which what we'll do here, as I told you earlier, we are going to use the embedding part. For the embedding part, we had a couple of options, right? But for the best approach, we are going to use the transformer file. We are going to use the transformer libraries here, and as well as when we move further here, we also do have the option such as if I talk about the modeling part, if I talk about the multiple thing here, right? So for the embedding model, as we discussed earlier in the LLM part, we do have this kind of approach here. You can observe in this config.py file. As I told you, for the LLM, we have the Gemini. For the embedding, we have the all mini LM L6. Right? Okay. Now, when we talk about this one, embedding.py, what we'll do here, we will use from sentence transformer, import the sentence transformer. I would say import the config here, import the config, right? And I'm going to give the simple approach underscore model equal to none. Model equal to none. I'm going to give def get model and I'm going to give global. I would give global underscore model. Global underscore model. If the model is none here, if I do not have any model, model is none here. What we'll do here, I will print something here. Print. We will use abstring here from the Python. Loading embedding model. Loading the embedding model. Loading the embedding model, right? And what we do for here, we are going to use the config embedded model. How can I do that? We will always use this config dot embedded model here, right? And then what we'll do here, we are going to keep move further. I would say after the print, I'm going to give sorry, model part, model equal to, I will give the sentence transform model, right? I'm going to give the config.embedded model. It will choose a configuration from a config file and it will work with the embedded model. Embedded model, right? And now the function is done. So what I will do now, I'm going to type return the model, because I always need a model here for our course file. This is how we design our things. Now, this is how we build one function in the embedding.py file. But when we talk about the second function, what we'll do here, we will create one other function def embedded. I would say text, right? And I will give the simple approach model equal to get model, right? I'm going to give vectors as well as, I would say vectors equal to model dot import part, right? Model dot import, and I would give the text here. Text is appear here, and I would give the convert to the numpy. I would say true. What I will do for approach here, convert to the true. So if you observe properly, this is how we are going to perform all the thing here. And as well as what we'll do here, we'll normalize the embedding part. I would say true here. And the last part we have show the progress bar here. I would say false. I don't want to show the, I don't want to see this entire process as per the approach here, right? Okay. Then for approach here, what we'll do now, I'm going to choose a return. I would say return my vector to the list. Return my vector to list. I would say return my vector to the list. Vector to list here. List. List here. Right? This is how we build up each and everything. I hope that's clear to everybody, right? Okay. So this is how we are going to build, this is how we are going to perform this entire thing one by one. So whenever we talk about the embedding of UI, in which what we'll have it here, we have the simple approach. We are going to set up two functions here. Number one, we have the get underscore model. And the second function we do have, it's called this embedded model. So whenever we talk about the number one model, as you already aware of this, right? We are going to use embedding here. We are going to use PromoDB, and we also have to use a phase. So if you use a multiple approach here, you can get the very good idea here. When we talk about the sentence part, when we talk about the transform part, that means if you got the one sentence here, if you got the multiple approaches to this, whenever the user will type the input as a prompt, it is always going to be divided into the chunk of the variable. Let's suppose if the one user is asked a question here, it will decide in multiple approach. Let's suppose one user is asked another question, it will be decided into different questions here. Let's suppose question is here, but the question is going to be divided into this multiple chunk of approach here. This is how we are going to set up. This is how we are going to build our embedding.py here. So if you observe here, what we do here, LLM, because the thing is that LLM cannot directly understand the plain text or the similar text. For that case, what we do here, we must need to convert, we must need to always convert our data, always our code, and text into this vector here. Then only the machine can able to understand what we want to do. Because machine cannot able to understand the human language. That means LLM cannot able to directly access our words. That's why we need to convert our entire data, entire work into this vector part. That's the reason we are going to use the embedding here. We do have the sentence embedding is here, vector embedding is also here, right? Multiple approach. And it's for the sentence transformer library. And we also need to import this config file, right? After that, what we'll perform here, we will use the multiple things here. Let's suppose I'm going to use here the all mini LM for a better approach, right? And then it always going to be stay in our entire RAM. So let's suppose if you want to find out, if you want to really want to know about how the thing is going to work, you will always get to know, you'll always get to have the idea about what you want to go for, right? And as well as whenever we talk about here, we're going to be converting to this different things here. I hope that's clear to everybody, right? What I'm trying to say here. Okay. So far so good. I hope so, right, students? Okay. And as well as what we do after that, we got the vector in this entire number. But let's suppose if you got the vector, it always convert. It always going to be converted into this 0.20, 0.30 here every time, right? So if you observe properly, this is how we had designed our config.py. We had performed this embedding. And as well as if you observe in this config.py, we had always give the configuration part about our model, which model we had used for the LLM part, which is the model we had used for the embedding part here. And as well as if you move further to the embedding part, in the embedding part, what we have performed here, students, if you observe very properly, you will get the more and more idea in the detail here. So when we talk about the embedding.py, in which we had choose which model, in which we are going to choose which model we had used for the embedding performance here. And as well as if you observe the LLM part, LLM.py, it is specially designed to work. It is specially designed to get a more and more idea about this LLM part. Because the large language model is always going to give you a lot of kind of error. So that's why we have set up the few function here to get rid of this error. We don't want this kind of error each and every time. That's why we had set up with the user from system prompt, right? And as well as we had also set up with this env part. This is how we are going to perform this config, embedding and LLM. So I hope that's clear to everybody, right? Then we can easily move further from here. Right? Can we move further, students? Okay. So after that, what we'll do here, we will also going to create a few also file. We're also going to create a multiple file as of now. But if you observe this memory.py file, you can also here, if I talk about this new button, right, you will see the more and more idea. I'm going to give the memory.py here, right? And it will give you more and more output here in this memory.py here. So if you observe here, what we have the multiple layer here. Number one layer, we have the memory layer. We also do have the fact storage also appear here, right? And as well as if I talk about the import OS, JSON part, time, and then config part. What I want to perform here now, I'm going to copy this code from my document here. Let me find out the memory.py here. I will find out the memory.py from here, and you will get a more and more idea here. Okay. Let me get this file here. Let me look out the file memory.py here, and you will get a more and more idea here. Okay, this is our file. So if you observe here, you will get this entire bunch of things here. We do have this certain kind of layer. I'm going to copy this file from here, memory.py file, and you will get this entire kind of idea, right? Let me copy this from here, and then I would paste into this new file here, memory.py here. You will get the more idea, right? So now what we had performed here, if you observe here, you will get this for the idea here, students, right? Okay. So whenever we talk about this layer, it always has a three kind of layer. Number one, we have the conversion buffer. That means the RAM part. So when we store some data here, it's always going to be stored in the RAM, right? And there is a high chance it can be look for the short-term memory if I store the data in the RAM, right? And as well as if I want to store the data in the fact table, it always going to be stored into this JSON format, right? And the last part, third layer we do have, it's called the rag over the PDF. That means it always going to be stored in the store.py and then PDF rag.py. After this memory.py, we are going to create store.py and the PDF underscore rag.py. If you get those both of the file, then only you will get the more and more idea. And students, if I talk about this bunch of things, before we move further, you must need to install the required package of the library here, then only it's going to be work for you. Right? So if I talk about the OS part, if I talk about JSON, if I talk about the time and each and everything here. Now, what we had performed after that, we had created one class here. If you observe here, you will get this more and more idea. So when we talk about the conversion here, conversion buffer, if you get the memory layer, number one layer conversion buffer, it is for the short term. Let's suppose you store some data here and data you are getting stored here after the few hours, after the few days, it is automatically removed from your memory. This is called the conversion buffer. But when we talk about the fact store, it is for the long term. Let's suppose if you had stored the data one day ago and you are going to retrieve those data after 5 years, 3 years, you will still have the chance, you will still have those kind of chance to retrieve those data again. That's mean that the simple meaning from here it's called fact store. That means when we talk about the fact store, student, you will get this idea. When we want to perform, if you want to store the data for the long period of the time, we will always use the fact store table. And it always stores the data into this JSON format. This is how we design, this is how we are going to build our entire memory layer for our entire project. And our main goal is here, memory agent here. We are going to perform the memory agent part. So I hope that's clear to everybody, students, right? What I want to perform here. If you observe here, we had created the class here for the short-term memory, and what we had choose here for a better. Let's suppose if somebody asks your name, it is remembering your name. But after you close your project, it cannot able to store your, it cannot able to retrieve your name here. It is forgot. This is called this conversion buffer. When you talk, it's remember, but when you switch on, it doesn't remember. If you start from if you restart the system here, it cannot work. This is called the conversion buffer. It cannot remember you properly, right? Let's suppose if there is a user A, his name is Alex, right? And if I ask the question, if I use a input here, like say my name is Alex, right? And then if I work here, it will always remember my name here as of now. But when we switch off this one, when we close the VS Code, when we close our code, right? And if you start from the scratch, when we start from the scratch, students, here what we can see here, our data, our all the thing cannot be work here. Let's suppose the conversion buffer here, it will going to be look like a short term memory here. It always going to be look like a short term memory here. That means if you use it properly here, and even after your data, your all the work going to be forget here. It cannot remember you properly after the few times after the shutdown here. After you shut down your system here. But on the other part, when we talk about this multiple thing, let's suppose the fact table. So in which we use a JSON format. It always going to be remember you properly for this entire bunch of period of the time. If you give the detail, like say I always like to do the shopping here. You are also going to work on the hands-on part, like the live performance part, live checking if the model is working or not. But I just want to let you know few ideas before we get into this. Right? Okay. If I talk about this long-term memory, as I words this long-term, it always going to be remember your detail as per the long-term, as per the long period of the time here. Right? This is how we are going to build up. So I hope this is clear to everybody, right, students? And if you observe here, we had created a bunch of function here, like say the load function is here, the save function, right? Add a file, forget a thing, and multiple things. So my entire goal is that I want to use a buffer terms. You can see the buffer terms. If you observe the code here, you will get the buffer terms. Buffer terms. You will get this idea here. Buffer terms. So what I had done the buffer terms 1, 2, 3, 4, 5 up to 6. You can see buffer terms here. Can you see that? If I look for here, the buffer terms, you will get this idea. Buffer terms, you can see it. That means one, the two, the three, four maximum message is going to give you this idea. Buffer turns here. If I use a buffer turns equal to 6, so I can maximum I can talk with the user, and then the AI part is going to be limited to a 6 entire message. This is how we limit our work, our conversion buffer. And as well, we can also limit our memory. So if you observe here, I have chosen maximum into multiply with the 3. That means maximum memory I can use it up to this 3. Like suppose user 1, user 2, user 3, user 4 up to this entire message is going to be worked into the 3 different categories here. Right? I hope that's clear to everybody, students, right? Whatever we have performed here. And if I talk about this second option, as I told you, fact talk, in which every data, every talk, sorry, not a data, every talk, if I am a user, I'm talking with the AI, I'm talking with the Gemini here, and whatever the talk we had, whatever the talk had performed with between two of them, let's suppose the user A and then the LLM part, it always going to be stored in this fact JSON here. It always going to be stored in the fact JSON here, in the JSON file, right? It use the constructor here to perform a multiple task. Right? So I hope that's clear to everybody, students, whatever we have performed till now, right? Okay. Then if you observe here, what we need to do after that, you also need to perform the few things as we are going to build up a multiple file. As I told you earlier, we must need to create two files. First of all, the stores.py and the pdf.rec.py. Let me create the store.py here, stores.py here, store.py here. And what I will do here, if you observe here, that's mean we are going to use now the backend part. Let's suppose the chroma DB, right? Let's suppose the phase here. So I'm going to choose a backend part as a chroma DB and the phase. We can switch between both of them. We can easily switch between one to another at a most convenient level. So when we start up this entire thing, you can observe here. Let me go back to my document here. Let me find out the store.py from here, right? Then you will get this idea what I want to go from. Let's suppose we have the two vector DBs. Number one is the chroma DB, second is the phase. If I want to switch between one to another, I can easily swap between one to another. Let me copy this entire code, store.py from here. Then I'm going to paste this same code in my VS Code. You can see this. So now, what I want to perform now in this store.py here, you can get the will give you more and more idea here. Embeddings is here. Let me copy this embedding is here. Let me rename this file here. Let me rename this one. Right, embeddings is here. That's why we are getting this error here. It is gone. So when we talk about this file, stores.py. So for the memory part, we need a two file. We need a third layer, stores.py and then pdf.rec.py. So I hope that's clear to everybody, right, students? What I want to perform here, what I want to tell you now here. I hope that's clear to everybody. Okay. So if you observe here, whenever we are talking about this, the conversion buffer and then fact store, conversion buffer for the dedicated memory, for the short-term memory. But when we talk about the fact store, it always gives you the idea for the long-term memory, right? And as well as the third layer, it always give you the idea for the store.py and the pdf rack.py is appeared. So I hope that's clear to everybody, right? And as well as if you observe here, you will get a more idea in this file stores.py. Why we use it? We want to swap between the live demo. If I want to swap from ChromaDB to the face store, we can easily swap it, right? And as well, what we'll do here, if you observe here, whenever we talk about those things, let's suppose the ChromaDB in face here, we have the multiple approach add is here. If I want to add something, if I want to query something, if I want to count something, you will get entire idea here. Right? So vector store, that means if you write down something like say the Python is a programming language, right? So it always search for the Python. It always look out for the one word. This is called the vector DB. It is called the vector. And if I talk about the vector database, so when the database is going to be able to store, when the database is able to store the vector in this database, it's called the vector database here. It's always going to be convert your vectors, convert your text into the vectors. That means the embedding part. This is called more and more approach. And if you want to perform, you will get a more and more idea when we talk about the semantic similarity. You're always going to find out the word which is best, which is always going to be similar here for approach, right? So if you observe here, let's suppose the user will give the idea. AI use the machine learning. And from your source of the PDF, it will give you the score. It will always going to give you the score 0.9, 0.8, 20. So if you got the more score, if you got the more similarity on your board, if you got the more and more similarity in your board, it will give you the written back, it will give you the written output. This is how we are going to design, this is how we are going to build our entire bunch of model. right? In the memory part, we'll give this kind of thing. It always going to work in the memory part. It always store the data. Let's suppose for the JSON file, for the fact store, it store the data in the JSON format. For the conversion, it store the data in the normal format. Here you can see this thing. So each and every part. But when we talk about the store.py, this is how actual data is going to be stored. You can see, you create a class ChromaDB. It store the data in the ChromaDB, right? You can see the document here one by one appear here. If I talk about this, you will get the more and more ideas. I hope this clear to everybody, right? You can see this entire thing is going to be worked. And if you observe here, if you talk about the second file, after the store.py file, you will get the each store add, query, count, reset. You can perform every task when we talk about the stores.py. Now after the second file, it is really important file. It's called the pdf underscore rack.py. Let me also give it a name here, pdf underscore rack. Retrieval augmented generation here as p1. Right? Let me open the document here. Right? And let me copy the file from here, pdf underscore rack.py. I'm going to copy this one and let me go back to this pdf rack. I'm going to paste pdf underscore rack. So if you observe here, you will get this idea about your data. Let me also give it a try one more time. Right? Let me copy this one. Let me paste it here. So in this rack file, what we'll do here, let's suppose it will read a PDF. It will always split into this multiple chunks, and from the every chunk, it is use a vector DB. It is use a vector DB store to get the retrieval from the most similarity of your context. Let's suppose if you ask the question for the what is a AI, it's always going to find out the keyword AI from the most matching and most convenient word from your vector DB from your storage, from your backend part, and it will give the output as per your storage. So read a PDF, extract all the text and as well as speech. It always going to be split your text into the chunks and store those chunks. It always going to be store those chunks into this vector DB as a chroma DB or a face we had used for our project. Right. So if you observe in this rag layer, we have the simple approach. We are going to use a multiple bunch of libraries, PDF reader is here, then we create a function, then we create a multiple function. If you know about the chunking size, right, you'll get a more and more idea about it. Then we use a while loop, if and else loop, right, to get the more and more idea. Then we will wrap up all the thing into this one function. It's called the depth chunk tanks, right? Depth chunk tax is here. Then we ingest all the thing, reading, chunking, embedding, and store the PDF. Simple flow. Read the PDF, convert, then do the division of the PDF into multiple stores, multiple types of different approach. PDF is like say 13 MB, right? We'll store into this 10 MB of the store, then embedding each and everything and store the PDF as a vector DB into the vector DB as a chroma DB or phase approach. Right. And if you observe here, students, you will get a more and more idea about that. So whenever we talk about this thing, you will get the more and more idea about this PDF underscore rack dot py here. And when we talk about the PDF underscore rack, you will get a more and more idea about this is how we are going to build up. Let's suppose if we talk about the file PDF underscore rack, and if we talk about another file, you will get a more and more idea. So I hope that's clear to everybody, students, right? What I want to let you know here. I hope that's clear to everybody, right? Okay. And if you observe here, you'll get a more and more idea about this PDF underscore rack. This is how we are going to build up a PDF underscore rack and the stores.py. So we do have the two files. Number one file as a stores.py and the second file we do have it's called this PDF underscore rack. This is how we are going to design each and every file, each and every model here. So I hope that's clear to everybody, right? Students, what I want to perform here, what I want to let you know. I hope that's clear to everybody, right? Students. Okay. Now, if you observe here, the main file, the main brain of the file is called the agent.py file. Agent.py file for more and more approach. Right? Let me give it a more idea here about the agent.py here. I'm going to open this agent.py. Let me open this file here, agent.py here. Let me copy from here, right? Let me going to copy from here to here. I'm going to copy this file here. And what we'll do after that, open the VS Code. and creating the file. I will give you the name as agent.python. Paste it here, and then you will get a more and more idea here to here. This is how we are going to perform. We have the multiple kind of layer one, layer two, layer three, right? You can see this conversion buffer, the fact store, the vector store. From the config file, you are going to install this one by one thing. In the system node, we have this. You are the helpful assistant with the memory part. Each and everything will be appeared. We had user rag part for the documentation purpose, right? Layer one conversion, fact layer, backend part is also involved. And we had use a document memory rag part to upload our document. And if you observe here for the long-term fact, what we had used a long-term part. Let's suppose for the remaining part, we had used this multiple approach here. As per the step-by-step approach, we had used this kind of things here. I hope this clear to everybody, students, right? What I want to let you know here, right? Okay. So if you observe here, whenever we talk about here, the agent.py file, it has a core data, but we must need to understand the one more file. It's called the main.py file, the CLI part, the main file, right? Okay, that's fine. Main.py. So what I want to do after that, let me copy this thing here, right? And I would say, sorry, the main.py here, Python file, right? The main file will run here, in which I had designed the CLI part. You can observe here. We can easily work with the command part. Let's suppose if I want to upload the PDF, I would say upload, and my part of my document here, I can upload the document. Let's suppose I want to chat with my message, I can easily chat with that. Let's suppose I want to perform the thing easy, I can easily do with this. This is how we are going to build up each and everything. If I want to check the fact table, if I want to do the multiple approach, this is how we are going to set up our insight. I hope that's clear to everyone, students, right? What we'll do here now, we are pretty much ready with each and every file, agent.py, config file, embedding data for the embedding part, LLM part, main file, memory part, right? Rag part is here, and then stores part. So config.py for the configuration part of the LLM part, the LLM is going to connect the configuration to the LLM here. Then we have this part is called the memory part for the memory purpose here, right? So we do have the two approach here. Let's suppose if we talk about the memory part, what we have it here, we have the simple approach for the vector DB. We have the two approach. Let's suppose if you want to store the data, we can use comma DB. And as well, we have already performed. Second thing is called the phase shift. But whenever we talk about this entire kind of thing here, what we can perform here, we can easily use multiple kind of approach. Let's suppose if I want to use a rag here, data development generation here. So how can I do that? I'm going to use the rag, and then rag is going to be convert my data into the different bit chunks of the part here. Then after that, it will always going to be convert my all the data into this vector DB. So when we talk to the LLM, it will give you the more and more retrieved version, more and more best performance as per the convenient. And if you observe here, when we talk about the graph, predictable augmented generation, it always going to give you the more and more idea. It works really, really great with the PDF part, right? So what we do here, when we talk about this entire project, now we are set up with entire project, then we can easily run our project for a better approach. What we'll do here, I'm going to use simple approach here. I'm going to run my project one by one. Let me give it a try. So before that, what I need to do here, I need to open my file, right? I need to create an env here. Let me create the env here. Right? Then we'll get a more idea. So in the environment file, what I want to do here, I'm going to choose a Gemini API key. I'm going to give LLM part. So just give me 1 minute. I'm ready with my setup here. Then we'll easily move for that because I cannot showcase you my the API keys, right? That's the reason here. Let me pause for 1 minute. Then I'll be back. Okay. So if you observe here, if you observe here, students, let's get started, right? Now we are pretty much ready with each and everything here. You can see this. My setup is already ready. It's the same setup which I saw you. What I need to change here, I just need to update with my env here, but I cannot show my env here. That's the reason I'm waiting for some time. Then let's get started. So what we'll do here, we are going to run the project here, but how can I do that here? So for that case, you must need to understand about each and everything for the better approach. So let's suppose if I want to run my project, if I want to run my project here, how can I do that? I need to be understand about my things here. I need to run a few of the command. What we do here? I'm going to do the Python dot main dot py here. Then I'm going to run this. I'm going to run the Python dot main dot py. It will open the CLI for us, right? The command line interface for us. Then we can perform the entire into the CLI here. Yeah, you can see. I'm going to zoom in for you. I'm going to increase the size for you. You will get the idea. Can you see? The memory agent is here. The rec plus conversion part is here, and then long form is here. So number one option, if I use this slash here, if I use upload here, I can upload the file, right? If I want to do the chat, I can perform it here. If I want to perform this, I can get a more and more idea. So now what I want to do here, let's suppose, if I want to work with that, I want to perform the multiple bunch of things. Let me go back to my document here, students, and you will get a more and more idea. Now, how can I set up the entire thing? Because now you can see this is how we are going to get it, right? But when we talk about here, you will get this entire bunch of detail here. Right? Let me delete those things here, right? Let me delete this PDF file here. I'm doing from the scratch for a better application, right? Okay. So you can observe here now, as of now, I'm into this vector backend. It's called the Chroma DB, right? Let me run this one, students. Let me run this one by one here. Let me copy from here. You can run the one by one here. Upload the PDF file one by one here. You can see. So what I want to do for that, how can I perform that? So for that case, what I need to do here, I must need to upload those things here for a better. I would say upload, right? And before that, what I need to do here, I need to also give the link from here. Let's suppose I will copy from here, upload, and then I will give this company underscore policy here. What I can do for that? Let me find out the company.policy here. Okay, let me see that if I have the file or not. Okay, how can I do that? So for that, there's what I have here, what I have it here. I can easily, I can easily run this one, maxsample.py. This is our file, so we can easily set up, we can easily create the three different PDF file for our project, of course, right? So I would say Python maxsample.py here. So it will create, you can see now on the left side, when I run this code, Python maxsample.py, it is automatically creating the PDF for us. You can see number one, number two, number three. Then what I will do after that, I'm going to choose Python main.py. I'm going to run this. So if you observe here, when we use a max sample, it is always creating the three bunch of file as per our coding part. You can see in my code, I had already mentioned here how to make a PDF file. This is how we are going to perform. So if you observe now, this is how we'll get it. Okay. Then what we'll do after that, I would say here, I it will take few time. It will take a few seconds for now because we are setting for the first time. Then it will move. So students, I hope that's clear to everybody, right? You can see how can I do it. You can see. Now I would say, can you give my name? You can see. I didn't talk with anyone, right? That's it. I don't have any name. Okay, you can see. I would say I am Snape Patel. You can observe here. I will give my name here, right? I'm going to give it here, like say. I'm going to give it like this. This is my name, right? This Snape Patel is my name, and I remember this name. I remember his name. You can see. This is how we are going to go. Now, what I will do after that, students, let me close this. Let me open the spreadsheet. Let me open the files because I mentioned, right, this is my name. You must need to remember my name, right? Okay. Let me run this one, the Python main.py here. Let me run this one, the main file. So if you observe here, when we talk to the AI, when we talk to the LLM here, and if you use a vector DB, it always store my things here. But if I give you, let's suppose I give you the hi here, right? Let's see what will happen after. Yes. You can see it's giving me this kind of right. Now I say, do you remember my name here? I would ask the here, what's my name? You can see it cannot able to use this one, it cannot able to work on this because thing is that it always going to be work, it always going to give the source from this the entire thing. So if in the company policy, I would always ask, let's suppose I ask like so what is the company name? So if I talk about all the things, let's say if I talk about the notebook airline, if I talk about the Google AI Studio, you can see this one, the company policy company name is ACME Corporation. Let me open this company policy PDF file. That means whatever the information you are giving to the AI, that means it's always going to be retrieved from this PDF file. What are the PDF files? This is the PDF. This is how we're going to use the memory part, the rack part, and this is how we're going to perform this entire thing. So when we talk about a lot of things here, you will get multiple things. Now I would say remember, and then I would give the name. I would say remember my name. I would say remember my name is. You can see it's always going to be stored in the factory. Then what I will do here, let me close this one, right? And let me run this one from the scratch. So I would say here, first of all, I'm going to run my file, main.py file. I would say Python main.py here, right? And if I run this one, you will get this all idea, right? When I want to run this one here, Python main.py. Now, because in our last, you can see now the fact loaded with the 2. Earlier it was 1, but now it's updated with the 1. Now if I ask, what is my name? It is giving me the answer with my name. Can you see? It is saying, you can observe here, it always going to be look out for this fact loaded. You can observe here. It will give my name. You can see, can you see? This is how we can use fact table to store for the long term. This is how we will use temporary table to store for the temporal thing. And as well, this is how we upload the PDF here. And if you want to observe here, this is how we can retrieve the data from the rack with the retrieval augmented generation. So if you observe in the source part, if I, because a lot of students we had already used, you had already used the notebook element in your life. Right? So if you use a notebook element, it's always going to be similar here. In the source part, you can upload the document here. From the document, you will get it more and more detail here. So this is how we had performed the numerical part. So my entire project is going to be work on top of that. You can observe here, building the agent with the memory. So the agent can able to understand. So the agent can able to retrieve the data from your previous data, from your document sources data. If I want to retrieve the data, if I ask any question, it will give the answer. It's called the RAG view. If I talk about the vector DB storage part, the phase in the chroma DB, it always going to be store the data for the long term and as well as for the short term, right? I hope this clear to everybody, right? And if I use this fact here, you will get you can run each and everything. So it totally up to you, right? It is no issue. If I use facts here, you will get it all. I am the vegetarian. I am the human. So this is how we will build the one entire project with the memory setup, the LLM part with the memory using the RAG, retrieval augmented as with the vector DB, chroma DB, and the phase. So as per the today's, this is how we are going to build up here, and this is all from my side as per the today. We will keep move further. We will meet. We will see you. We will see you with the next session, right? So this all from the my side as per the day number 3, right? And then bye bye. Take care. See you soon.